3D scanning is a growing field with many applications in fields such as manufacturing, design, fabrication, and simulation. However, many current 3D scanning applications are expensive and require industry-specific knowledge. This can be prohibitive to consumers and smaller companies who may not have the capital or required expertise to invest in 3D scanning technologies.
As a group of engineering students, the LiDART team wanted to create a 3D scanning robot that is low cost and user-friendly so that it can be used by the widest audience. LiDAR does not require expensive or specialized hardware, nor does it require that the user have any specific knowledge.
Users of the LiDART robot include parties that would benefit from low-cost, easily accessible 3D scanning. Examples of groups that fit this criteria include visual effects studios, independent mechanical designers, and manufacturing firms, as well as hobbyists.
We decided to create LiDART since we found there was a gap in popular 3D scanners. Most of the models can only scan a fixed dimension. Some of the largest scanners can cover a width of 2 meters. However, LiDAR can cover an object of any size, given a large enough room.
The LiDART itself was designed to fit inside a 2-foot wide box. It incorporates simple off-the-shelf parts in order to ensure ease of assembly. These include a Raspberry Pi, Arduino, stepper motor, and a belt, as well as large batteries. In order to make scanning as trouble-free as possible, the lithium-based batteries provide for a 30-hour runtime.
Also included in the LiDART is a steel frame, 4 rugged 3D printed wheels, and a vertical elevator.
Completing a scan on the LiDART is simple and consists of 4 steps. Setting up the robot for scanning is a simple process. The robot can be connected to using any personal computer through a web browser. An intuitive user interface is used to control the robot.
The next part of setting up the robot is populating the surrounding environment with landmarks. The LiDART robot integrates with April tags, a robust visual tagging system. These landmarks can be printed on standard printer paper and attached anywhere in the environment surrounding the robot. The accessibility of these landmarks allows the robot to be used in any desired location.
The robot can be controlled using arrow keys on a keyboard or the popular DualShock controller platform. Its motors allow it to turn in place, giving it mobility for even the toughest terrain. The live camera feed allows the robot to be piloted remotely.
In order to initiate a scan, the user will instruct the robot to start from the graphical user interface. The robot will then scan at multiple levels in order to produce a 3-dimensional point cloud. While the robot is scanning, live data is populated on the UI. This allows the user to troubleshoot issues during scan time instead of having to wait for the complete data. The file can then be downloaded in the popular PCD file format.